Hello friends, welcome to kodEdge. In this video, we will learn how to set up an automated CI/CD pipeline using Jenkins. Let's first understand the CI/CD setup that we will be building in this demonstration. First, we will create a multi-module project. We will develop a SpringBoot application using the Gradle build system. Next, we will add modules like app, domain, port, REST, and a smoke test to the project. Don't worry if you are not familiar with these modules. I will explain each of them in detail shortly. Once our project is ready, we will add a Docker file to containerize the application and Helm chart for managing the Kubernetes manifest configurations. After that, we will push our project in the GitHub repository. Then we will set up a Jenkins pipeline. The first stage in the pipeline will be checkout, which will pull the code from the GitHub. Next stage will be the build stage, where we will compile the code and create a jar file for the application. After that, unit test stage will run unit test on the application. Next stage will be the smoke test. This stage will run the functional test, or what you may also refer to as end-to-end test. Next stage will be the code analysis stage, where we will use SonarQube for the code quality analysis. Following this, the build and push image stage will create a Docker image of our application and will push it into the Docker Hub. Next stage will be the deploy on a dev, where we will deploy our application to the Docker environment for the development purpose. During deployment, Docker will pull the image from the Docker Hub that we will push in the previous stage. The health stage verify the health of our application once it is deployed in the development environment. Finally, the last stage will be the update image tag, where we will update the Docker image tag in the values.yaml file. Values.yaml file is used for the Helm chart, which serves as a default configuration for the chart template. I will explain the values.yaml file when we will develop our application. Then we will configure the ArgoCD in the Kubernetes. For this demonstration, we will be using Minikube as our local Kubernetes environment. Once values.yaml file is updated with the new image tag, ArgoCD will automatically fetch the changes from the GitHub. In other words, ArgoCD will read the image tag from the values.yaml file and it will redeploy the application. To do this, it will recreate the pods by fetching the updated Docker image from the Docker Hub. Once it deployed, our application will be ready for the use. In our CI/CD setup, you can call Jenkins pipeline as a continuous integration and ArgoCD setup as a continuous deployment. Typically, deploy to dev should be part of continuous deployment, but as we are using Docker, that's why I kept it into the Jenkins side only. But if you are using Kubernetes for the deploy to dev stage as well, then you can handle the entire deployment process using ArgoCD. As you can see, our setup involves multiple integration with various components. To simplify things, I have divided this video into the several steps. First step will be the develop multi-module project. Next stage will be set up Jenkins and SonarQube server. Third step will be the create Jenkins pipeline, and last stage will be the ArgoCD setup. Develop multi-module project. Let's start understanding the application that we are going to build. We will create a simple exchange rate service. User will call this service to get the latest exchange rate of a particular currency. For example, here USD. Now the exchange rate service will call the external service to fetch the latest exchange rate. Once it receives the response from the external service, it will process the data and it will return the requested currency exchange rate. So you can see in the response, it will have available conversion rates in the map. Now let's break down the modules in our project. We will be developing a Spring Boot project using Gradle as a build system. The first module will be the domain module. The domain module will contain all business logic and all other modules will be dependent on this domain module. So next module will be REST module. This module will expose the public APIs. It will handle all user requests. So build.gradle file of the REST module will include dependency on the domain module, as it will rely on the domain module to fetch exchange rates. Next module will be the port module. This module will interact with the external services to fetch the exchange rate data, convert response into the appropriate format for the domain module, and pass it to the domain module. Hence, the port module's build.gradle file will have dependency on the domain module. Next module will be the app module. This module will initialize all the dependencies and bindings in our application. And this module is dependent on all the modules. So its build.gradle will include dependency on all the other modules. Finally, we will have a smoke test module. This module will contain functional, or you can also say end-to-end test for the application. As you can see, all our modules are dependent on the central module, that is domain module, as it contains the core business logic. All other modules serve as a supporting component. So let's say in future, if we want to add a new module, such as a repository module for the database operation, then this module will also dependent on the domain module. So domain module in turns will not depend on any other module. This follows the hexagonal architecture pattern for the microservices. Once the application is fully developed, we will dockerize it by adding the Docker file and necessary Kubernetes manifest configuration, which we will manage using the Helm chart. So let's create a new project. I am using Spring Initializer to create the project template. So build system I am using as a Gradle. This is the latest Spring Boot version while recording this video, and JDK version I am using as a 21. Let me give the group name. So I am giving name as a com.kodEdge. Artifact name or the project name I am giving as a exchange rate. And let's add the dependency. So first dependency will be for the web. Next dependency I am adding for the actuator, using which you can get the endpoints to monitor your application. So let me generate this project and let me open this project into the IntelliJ. So in this project, we are going to add multiple modules. So let's add the modules. For that, what you can do, right click, click on new and select the module option. And here just add the name for the module. So let's add the new module, that will be the port. Build system will be the Gradle. And let's use the JDK version 21. And let me create the module. Let's add the other modules. So next module will be the domain module. Let's add the other modules. So it will be the REST module. Let's add one more module. That will be the app module. And the last module will be the smoke test. Okay, so these are all our modules that I explained in the slide, correct? Now what we will do, we will change the code in the build.gradle file. So let's open all the modules and remove all the code from the build.gradle file. Open the build.gradle file and we will change the structure of this build.gradle file. So let's remove this version. Then next will be the repository, it will be the same. Next we will add the boot jar enable property so that we can create the jar. Now let's add one more property here, that will be the sub project. And in this sub project, we will move these dependencies. Next, we will add some plugins. So it will be Java plugin. Next plugin will be for the Spring Boot, and last plugin will be for the dependency management. Next, let's add the repositories section here. Okay, let's move this task into this sub project for running the unit test. Now let's add few dependencies. This will be for the Spring Boot. These two dependency we are going to move, and this dependency we will add into the app module. I will explain that later, but let's comment these two dependencies now. Let's add a few more dependencies for the test, and let's skip this web dependency as well. So what is the purpose of these dependencies? All these dependencies will get used by all the modules, And within each module, we will add particular dependencies that is related to that particular module. Let's remove this and let's move into the app module. Okay. So what we will do, we will remove this code. Just delete this code from here. And let's open the build.gradle file of the app module. And let's add dependency here. So I'm adding starter web and the actual dependency. Next, we will add a dependency for the all the modules. So it will be like this. And here we will add the dependency of the module. So let's add the name of the module. That will be domain. Okay. Like this, we will add the dependency for the other modules. So what is the purpose of this app module? It is going to inject the dependencies for the all the modules, or you can say all the configuration required for this project we will do in this app module. Let's add few more tasks here. So this is for the JUnit, and this is for the creating the jar file, and jar name will be exchange rates. Now let's add a package here in the app module. Package will be com.kodedge.app, and let's move this class into the app module. Okay, let's delete this package from here. Okay, so we are not going to use this src folder. Now let's refactor our exchange application class. Okay, so it is giving some error. So let's add one property here in this annotation. That will be scan base packages. And let's add the package name, that will be com.kodedge. So what this will do, this will inject the dependencies for the classes which are in the com.kodedge package. Now let me reload the Gradle. Okay, you can see all the dependencies are resolved. Now let's go into the parent build.gradle file, and we can see if there is any error. Okay, so there is no error in the build.gradle file as well. Okay, so let me close all the files. Now next what we will do, we will create the classes in the domain module. So let's create the new package com.kodedge.domain, and let's add the new model class, that will be exchange rate. Now here we are going to call the external service, right? And when we receive the response, we want to convert that response automatically into this exchange rate object. So for that purpose, we are going to add few more dependency. So let's open the build.gradle file, and let's add the dependency for the Jackson. Let's reload the Gradle, and let's go back into the exchange rate, and let me copy paste the object class. Okay, so what we have added here, we will have a base currency, we will have rates, and we will have last updated date for that particular currency. Then I have added the constructor. Then these are all the getter and setter, and this is the toString method for this object. Now next we will create one more package, that will be the client package. And here we will add the interface for the client. So let me give the name for the interface, that will be exchange rate client, and this will talk to the external service. So it will return the exchange rate object, and method name will be get latest rate, and it will accept the currency which we want to convert. And for this, we will add the implementation into the port module, but we are adding the abstraction in the domain module so that it should not directly dependent on the port module. Now let's add the service to call this latest exchange rate. So let me create a new class here. Class name will be exchange rate service. Now let's add the annotation for the service class, that will be service. And let's auto wire the object for the exchange rate client. Let's add the annotation that will be auto wire. And let's add the method exchange rate get exchange rate. And let's change the parameter name that will be the base currency. And what it will call? It will call this get latest exchange rate. Correct? So this is our service call. So it will return this exchange rate object. And if you go back into the exchange rate class, I have added one property here, that is JSON properties, right? So what it will do, when we will receive the response from the external service, that Jackson, it will automatically map the JSON response based on this JSON properties name. Okay, so this base rates last updated, so this key will be in the response from the external service. Okay, so our domain module is ready. Now next what we will do, we will develop our port module from which we will call the external service. So for that, let's create the external service. So we are not going to develop a new service. We are going to use some mock website. So let me open the browser. And for this purpose, what we are going to use? We are going to use this designer.mocky.io website. So here you can define your mock API and it will generate a URL from which you can call the API. We will going to create API which will return the status as OK. Response content type will be the application/JSON. And let's add the response sample response body. So this will be the sample response body. So base currency is USD, and these are the all the available rates for conversion of this currency. Like if you want to convert the USD to the AED, so conversion rate will be the 3.623, and this will be the last updated date. And now if you see these keys, base, rates, and last updated, these keys are going to map with this JSON properties keys, and this response will automatically get converted into the exchange rates object. So let's create this API first. So we are not going to use any security token or a modifier. Let's generate this HTTP response. Okay, so this is our mock URL. So let's go back into the project and let's create the new package in the port module. Package name I'm giving as a com.kodEdge.port. So let's add some configuration class. So class name will be app_config. So this class we will use to create the bin for the REST template. So let me copy code for that. Okay, so this is the configuration. So what we are doing here, we have created the app_config. We have annotated this class with the add configuration annotation. And we are creating the two bins here. So first bin we are creating for the REST template. And second bin we are creating for the object mapper. So using this REST template, we will call the external service. And this object mapper we are going to use to convert our JSON response into the exchange rate object. Now let's add our API URL in the application.properties file. So let's create a new file here. And I'm giving name as a exchange rate-mock.url. And let's copy paste that URL from the website. So this is a mock URL. And let's invoke this property into the class. For that purpose, we'll create the new class. So class name will be exchange rate properties class. And this will be the code for the exchange rate properties. So what we are doing here, we have added the variable that is string URL. And here we have annotated this class with the add component annotation. Next, we are adding the configuration property with prefix as a exchange rates-mock. So this is the same prefix that we have added here, that is exchange rates mock. And next, here it will automatically get a map to this URL property from this .url properties. So what, as a summary, what this class will do, this will read this application.property file, and it will give this URL using this URL variable. Now next we will implement the interface that we have created into the domain module. So we have added this interface right in the client module, that is extended client. Now we will add the implementation for this, and we will call the external service. So let's create a new class here. Class name will be extended client IMPL, and code for this will be this. Okay. So it is giving some error, right? So let's go to the build.gradle file and let's add the dependency. So dependencies I am adding for the Spring Web, then Jackson. This is for the conversion of JSON into the extended object. And next dependency I am adding for the domain model, because we are using the extended client and the extended object from the domain model. That's why. And here I am adding the property bootjar enable equal to false, because I don't want to create the jar file for this particular module. Let's reload the Gradle and let's go back into the implementation class. So let's understand this class. So what I'm doing here, I just implemented this extended client interface that we have defined in the domain module, and it has a method get latest rate, correct? Next, we are auto wiring this object, that is a REST template and the object mapper, and which we will get this object from this app config class. Next, we are doing the auto wiring using the constructor injection. Next, we are also using the extended properties that we have created here. Now here we are implementing the get latest rate method. And here what we are doing, we are getting the URL from this extended properties.get URL method. Next, we are using the REST template dot get for object, to which we are passing the URL. So what will be the URL? URL will be this one. Okay. And this is coming from the extended -mock. And where we define this mock, we have defined this mock in the application.properties file. And this will return the JSON response. Next, we want to convert this JSON response into the extended object. For that purpose, we are using the object mapper, to which we are passing the JSON response, which will convert that JSON response into the extended.class. Correct? And we are not handling the exception properly here. We are just returning the null in case there is any issue. So our port module is ready. Now next what we will do, we will add one sample unit test in the domain module. So let's go into the test and let's create a package. Package will be com.kodEdge.domain. And we will add unit test for this service class. So let me change this method name, that will be get latest rate. So let me create a test. Test name will be extended service test. So this is required to mock the some method calls. So let me add the code for this. Let me rename this class to extended service. So first I am mocking the extended client, that is this interface. So in the service class, what we are doing, we are creating the extended client object. Then we are calling the get latest rate. So to mock this call, we are using the @mock annotation. Then I am using the next annotation, that is @inject mocks. This will create the object for the extended service. And using this object, we are going to call this get extended method, right? And we are going to test this method. So our first test is should return the extended. So this is happy path test. So here I have commented this thread.slip to demonstrate the SonarQube issue later in the CICD pipeline setup. So here what we are doing, we are arranging the mocks. So when we call this extended client.get latest method, it should return this extended object. And from where we are getting this extended object, so I just defined that dummy object in the same class. Okay. Now here we are actually testing this method, and we are just asserting this response with the actual response. So this is our expected response, okay, that we have defined here, and we are just asserting that response with the actual response that we are getting from this method. Okay, so this is very simple unit test. I have just added for the demonstration purpose while we are going to run the unit test from the CI/CD pipeline. So let's run this unit test. Okay, you can see it is successful. Okay, so our domain module is also ready and our port module is also ready. Now next what we will do, we will add the controller to call this service method that we have defined here. So let's go into the REST module and let's open the build.gradle file. Okay, so I'm adding dependency for the Spring Web, and here second dependency will be on the domain module. And here as well, I'm making the boot jar as a false because I don't want to create the jar file for this REST module. Let's reload the Gradle and let's create the new package. That will be com.kodEdge.rest. And here we will create the controller. Name will be extended controller. And this will be the code for that. So what I'm doing here, I'm annotating this class with the @REST controller annotation. Then I'm creating the object for the extended service using the constructor injection. Next, I'm creating the API, which will be the get mapping API, and I'm adding path like -latest, to which I'm going to pass the currency. And I'm accessing this currency using the path variable. So for that purpose, I'm using the annotation @path variable, and I'm accepting that string in the currency variable. Then I'm calling the get extended service, to which I'm passing the base currency, which will call the get latest rate. And this is a client. And this method call will go to the port module, right? In which we have defined the external service call. Okay, so our controller is also ready. Now next we will add the smoke test, that is end-to-end test for our application. So let's go into the smoke test module, open the build.gradle file, and let's add the dependencies. So here dependencies will be for the all the modules like app, domain, and port. And this is a dependency for the Mockito. Let's reload the Gradle. I think there is some issue with this module. Let me delete this module and recreate this module. Let's create that module again. Smoke-test, and let's create the module. Okay, so smoke test module is created. Now you can see it has added the source folder, and let's add the package into the test folder. Package name will be com.kodedge.smoke. Before adding the class here, let's add a dependency in the build.gradle files. Let's add the new class for the test. Class name will be extended controller smoke test. And let me add the code for that. So let's understand what I'm doing here. I'm just using the SpringBoot test annotation here, in which I'm defining the environment for which I'm using the random port. So what this will do, this is going to run the Tomcat, okay, and it is going to deploy our application on the local Tomcat, for which it is going to use the random port to call our controller API. Next, I'm defining the active profile, that will be the test. Then here I'm auto adding the test template, that is a test REST template. Here I'm defining the extended client object, which we are going to mock. Then this is a happy path test, should return the status code as a 200 for the response for the application health API. So what I'm expecting here, I'm expecting the 200 response for the application. That is a health endpoint. And this health endpoint is provided by the actuator. So what I'm doing here, REST template.get for entity, to which I'm passing the URL /actuator/health. I'm just asserting the response, that is http status.ok. Next test is for the getting the latest exchange rate for the currency. So what I want to do, I want to convert this base currency, and I'm just mocking the get latest rate API. Okay, so it will return this response. Then what I'm doing here, here I am calling our API, that is latest slash currency, that we have defined in the controller. So in the test, we are calling this API. We are not calling method directly because this is the end-to-end test. And here what we are getting, it will return the response. We are converting that response into the extended object, and we are just asserting that response. Okay, so this is our end-to-end test. Let's run this test. You can see both the tests are getting passed. Now if you see the console output of this test, it has started the Tomcat server. Okay, so our end-to-end test is also completed. Now next what we will do, we will add one task in the build.gradle file to run this test from the pipeline. So we are considering this test as a smoke test. So let's go to the parent build.gradle file and let's add the task. So that will be outside this sub project. So I'm adding task as a run smoke test. So I'm adding group as a verification, and this is a description, that is run all tests from the smoke test module, and this depends on this smoke test module. Now if you want to run the smoke test directly from the command prompt, what you can do, you can run the command like this /gradle w, and this will be your task name. So this will run your smoke test. Okay, so you can see it ran the smoke test from the smoke module. Now next what we will do, we will add the Docker file in our project, and we will try to run our project from the Docker. So let's create a new file in the parent directory. File name will be Docker file. Okay, so what I'm doing, I'm using the base image as a OpenJDK 21. Then this will be our working directory, and I am copying the extended jar file, which is going to generate in the libs folder, and I'm copying that jar file into this app directory. Then I am exposing our application using 8080 port, and this is our jar name, that will be extended.jar, and this is a command to execute our jar. So let me try to build our jar. So for that purpose, what you can do, just run the command /gradle w clean build. So it will run the unit test. And if you go into the app folder or app module, it has created the build folder. In the build folder in the libs, you can see it has created the extended.jar, from which we are copying this jar into this app working directory. Okay, so let's go into the command prompt and cd into the extended directory and run the command docker build -t extendeds dot. So this will create the Docker image. Okay, so Docker image is created. So if you run the command Docker images, you can see extended images created. Now to run the project, what you can do, Docker run -t your port, that will be 8080, and the image name, that is extendeds. Okay, so you can see our Tomcat is started. Now let's go back into the browser. So first we will check the health of our application. So URL will be localhost :8080 /actuator/health. So you can see we are getting status as up. Now let's call our API. That will be /latest/currency. That will be USD. Okay, so you can see we are getting the response from this external service. Correct? So this is the response that we have configured in the external service. Okay, so this is the same response we are getting from our application. Now what we will do, we'll push our code into the GitHub repository. So let's go into the GitHub and let's create the new repository. Here repository name will be exchange rates. So I'm making this repository as a private for now, and let's create the repository. Okay, so our extended repository is created. Just follow this instruction to push our code into the GitHub repository. So let me open the terminal and just follow these commands. So first command is git init. Next command is to add all the files from our local repository. So I am just doing git add dot. Okay, so it has added all the files into the commit. Let's add the message for the commit. Give message as a first commit. Let me make this m as a small m. Okay, so it has added all these files. The next command is git branch -m main. And let's add the remote branch. And let's push our code. So I already configured the username and password in my local configuration. That's why it is not asking the username and the password. So if you refresh this GitHub repository now, you can see code is pushed into the GitHub. Set up Jenkins and SonarQube server. We will run both Jenkins and SonarQube on local Docker environment. For that purpose, first we will develop a Docker file for Jenkins. Next, we will create a Docker Compose file that will set up a Jenkins SonarQube server and its database within the Docker. When Jenkins is up and running, we will configure the Jenkins login and set up the required plugins. After that, we will integrate the SonarQube server with the Jenkins for code quality analysis. So let's create a new folder CICD. And in this folder, let's create two more folders. First folder will be for the CI, in which we will provide configuration for the Jenkins. And the next folder will be CD, in which we will provide configuration for the CD, that you can say continuous deployment. So in the CI folder, let's create a file, Docker file. This we will use for the Jenkins purpose. So first statement will be to use the base image from the Jenkins. So this is the base image we are going to use for the Jenkins. Next, we will define the user. So we are going to use root user to install the following commands. So first command we are going to use for the Gradle. So we are going to install Gradle as we are going to build the Gradle project. So let's use this command. Next command will be to install the Docker in the Jenkins, because we are going to use the Docker image and we are going to build a Docker image in the Jenkins. So this is the command to install the Docker. Next, we are going to expose the Jenkins on the particular port. So let's expose the port 8080 on which Jenkins server is going to run. So next file we are going to create docker compose.yaml file. So in this file we are going to define three services. First service will be Jenkins, second service will be SonarQube, and third service will be SonarQube database. We are going to use a local database for the SonarQube. So let's define the version. Version will be, I am using 3.8. And let's define the services tab. And the services, first service will be Jenkins. And this will be the configuration for the Jenkins. So let's understand what I'm doing here. So this is the context. Okay. And here I'm defining the path, that is the local path, that will be this CI path. From this path, it will find the Docker file. And here I'm giving the Docker file path, that is Docker file, which will get searched into local directory. Then this is a container name. So I'm giving container name as a Jenkins. And these are the ports on which I'm going to expose the Jenkins server. Next, we are using the volumes. So I'm using the local volume. So this will be the local volume key. And this is the path for the local volume. And here I'm defining the socket. Okay. So we will define this volume at the end of this file. The next tag is network. So this will be the CI network that we are going to create in this file. Then these are the environments. So Jenkins underscore opt. Here I'm defining the port. And last tag will be the restart always. Now let's define the next service, that will be the SonarQube. And this will be the configuration for the SonarQube. So here I am defining the image that will be SonarQube LTS. Container name I am giving as a SonarQube. It is going to expose on 9001 port. Network I am using the same network, that is CI network. Then these are the some environment variables. So this will be the SonarQube JDBC URL. So this will be like this. Okay, so this will be the local URL for the database. Then next is a username password. So this will be the default Sonar and Sonar. And here as well I'm defining the volume. So SonarQube data, SonarQube extension, and SonarQube logs. So we will define this volume at the end of this file. And restart policy will be unless stopped. Now to run the SonarQube, it requires a database. So let's define service for the database. Okay, so this is the service SonarQube DB. Here I am using image as a Postgres. So it is going to install the Postgres, or you can say it is going to run the container for the Postgres on the Docker. Then container name I am giving as a SonarQube DB. And these are the some environments variable like Postgres username and password. Sorry. Then this will be the volume for the Postgres database. This will be the network, CI network, and restart policy will be always. Now let's define the network that we are using in this configuration. That will be the CI network. So for that purpose, what we can do, you can define it like this. It will be under the network tab. Network name will be CI network, and driver we are going to use bridge driver. Now last step will be to define the volumes. So these are the volumes we are using in this configuration. Okay, so our Docker Compose file is ready. Now what we will do, we will run this Docker file. So let's open the terminal and make sure is Docker is already started. So let's cd into CICD folder and let's cd into the CI folder. So command will be docker-compose up. So I'm using sudo user here because I get some issue while installing this command. So I'm using sudo user for this. If you don't get any error, you can use the docker compose command. And I want to run this command into detach mode. Okay, so you can see it is pulling the image for the SonarQube DB, and it will also pull the image for the Jenkins as well. So it will take some time to download the image. So you can see all the containers are created. So let me clear it and run the command docker ps. So you can see all the containers are started. You can see CI Jenkins, then Postgres, and the SonarQube. Now let's open the browser and we will open the UI for the SonarQube and the Jenkins. So let's use the URL localhost :8011. So first we need to find the password for the Jenkins. So what we can do, let's open the terminal and let's execute the command docker execute -it Jenkins. That will be the container name bash. Next, just go back to the UI and just copy this path and let's do a cat. Okay, so this will be the password for our Jenkins. So let's make a note of this password somewhere. Okay, so this will be our Jenkins password. Let's use that password and click on the continue. So let's install the default plugins. So click on this option, that is install suggested plugins. So it will take some time to install the plugins. Okay, so next it is asking for the creating the admin user. So I'm skipping this stage now. And I want to keep the Jenkins URL as localhost 8011. So click on the save and finish. Let's click on the start using Jenkins. Now let's click on the manage Jenkins. And if you go here in the plugins option, let's click on the install plugins. So here you can see all the install plugins. Now based on this, we want to install the few more plugins. So click on the available plugins and let's search for the SonarQube. Okay, so let's select the SonarQube scanner and click on the install. Okay, so it is installing. After installation of this plugin, let's click on the available plugins and let's search for the pipeline stage view. Okay, so you can see pipeline stage view. Just select this. Next plugin we will search for the Docker and it will be Docker pipeline. Okay, and the last plugin we will use pipeline utility step. So this is required for the Docker. Pipeline stage view and the utility step is required to show the stages in the pipeline. And SonarQube is required for the integration with SonarQube server. Let's click on the install. So all the plugins are installed. Let's click on the restart the Jenkins. So it will take some time to restart the Jenkins server. Now next what we will do, we will open the UI for the SonarQube. So URL will be localhost colon 9001. So login will be admin, password will be admin. Okay, so it is asking for the changing the old password. So I'm giving some simple password for the demonstration purpose. Click on the update. So this is our SonarQube UI. Now let's go back to the Jenkins and we will log in into the Jenkins again. So username will be admin and password will be that we have generated in the previous stage. So this is our Jenkins password. Now next what we will do, we will generate some tokens and we will store that into the environments variable in the Jenkins server. So let's go into the SonarQube server and here we will first create the token. So for that purpose, you can click on the administrator and in the security, you will find option for the user. So click on that and here you will find the option for the creating the token. So let's enter the token name. So I'm giving name as a Jenkins because we are going to use token for the Jenkins and click on the generate. Let's copy this token and let's make a note of this token. So next we will generate token for the Docker Hub. So let's log in to Docker Hub account because we are going to push our Docker image into the Docker Hub repository. So let me open the Docker Hub. Okay, so I already signed in to the Docker Hub and here you can create the new repository and you can give the namespace. Here I'm giving the namespace as a kodEdge and you can give the repository name here. So I already created the repository. So this is my repository. So you can give the name as a exchange rate. And here you will find the command how to push the Docker image to this repository. So to generate the token, what we can do, just click on this profile option here, click on the account settings, and here click on the personal access token. So here you can see I already created few tokens. So let's create a new token. Let me give the name as a Jenkins demo. So I am giving the access permission as a public repo read only. Okay, let's click on the generate and just copy this token. So this is our third token. So one more thing, if you notice this repository I have created as a private repository. Okay, so on the free account you can get only one private repository. Now let's create one more token that is for the GitHub. So let me go to the GitHub account and let's click on this profile icon here and let's click on the settings. And here you will find the option for the developer settings. Click on the personal access token, click on the token classic option here. And let's generate a new token that will be of the type classic. And let's create the token. So I'm giving as a Jenkins demo or YT demo. You can give any name as per your requirement. And here I'm providing few accesses. So you can provide access as per your requirements. And let's click on the generate token. Okay, so token is generated. Let's make a note of this GitHub token as well. Now all the tokens are generated. Now we will add all these token as an environment variable in the Jenkins server. Click on the manage Jenkins. Click on the credentials. Click on the system. Click on the global credentials and click on the add credentials. So first token we will add for the SonarQube. So let's select the secret. That will be the secret text. And let's copy that secret token here. So this is a token for the SonarQube, correct? So just copy this. And ID I am giving as a SonarQube. So just to make a note of this ID, because we are going to use the same ID in the Jenkins pipeline. Okay, so I am giving the same description here and click on the create. Okay, so we have added the first environment variable. Let's add one more environment variable, and this will be for the GitHub. So select username and password here. So my GitHub account username is code with Swapnilji. So password will be the token that we have generated. So this is our GitHub token. And let's give the ID. Again, please make a note of this ID because we are going to use same ID in the Jenkins pipeline. And let's create credentials. Now next credential we are going to generate for the Docker Hub. So click on the add credential. Kind will be username with the password. Let's use the username. So my username for the Docker Hub is kodEdge. And let's copy the password. That will be the token. And let's add the ID. So ID will be Docker Hub credentials. And let's click on the create. Okay, so we have generated all the credentials. Now let's go back to the manage Jenkins. And let's click on the system. And here we are going to create few environment variables. Okay, so let's scroll up and just find the option for the global properties. So just click on this environment variables here and let's click on the add. And here we will add environment variable for the Sonar host URL. So this will be the name for the Sonar host URL. That will be the environment name for the variable. And what will be the value? Value will be this SonarQube server URL. Now, as we are running this SonarQube server on the Docker, so URL will be somewhat different. So this will be the URL host.docker.internal:9001. Okay, so we have added environment variable for the Sonar host URL, which we are going to use in the Jenkins pipeline. Now, if you see the option for the SonarQube server here, let's click on the add SonarQube. So let's add the name. That will be SonarQube. And URL will be, just use this variable. So server URL will be, you can use this variable like this, $ in the bracket, Sonar host URL. And let's select the server authentication. That will be SonarQube because this we have added in the credential, correct? That's why that option is coming here automatically. Okay, so let's click on the apply and save. Now one more setup we need to do in the SonarQube. So let's go into the SonarQube server and click on the administrator and click on the configuration. And here you will find the option for the webhooks. And let's click on the create. So I'm adding name as a SonarQube webhook. So this will be the URL, that is host docker internal:8011/SonarQube-webhook. Let's keep the secret as a blank and let's click on the create. So what will happen when we run the Jenkins pipeline? We are going to do a SonarQube analysis, correct? And to get the result from the SonarQube, this webhook will get used internally. Now next what we can do, we can add some quality gates in the SonarQube. So click on the quality gates here. And these are some default rules that is used for the SonarQube analysis. So you can customize these rules and we can create multiple quality profiles here. and you can provide multiple rules or you can create some custom rules as well based on your language. So let's click on these quality gates and let's create a new quality gate. So I'm giving name as a test gate. Click on the save and let's click on this unlock editing and let's click on the add condition and let's add one condition. And when the code smell, let's select the code smell is greater than 0 and let's add this condition. Okay, so whenever there is a code smell which is greater than 0, the analysis will get fail. And let's make this quality gate as a default one. Okay, so click on this set as a default. So this is how our SonarQube and the Jenkins configuration is ready. Create Jenkins pipeline. As you can see in the diagram, we will configure all the stages. I have already explained the purpose of each stage and the flow in the introduction section. Now let's move directly into the setup. So let's create a new file that will be Jenkins file. Let's give it a name Jenkins file. And in this file, we are going to add multiple stages. So what we have to define, we have to use this tag that is pipeline. So let's use the agent. Currently, I'm using any agent here. And let's add the environments variable that we have added in the Jenkins server. So these are the some environments variable that we have added. So this will be our GitHub credential ID. Okay, so you can give any name as per your requirement, but make sure to use the same name in the further stages. So let me open the Jenkins and let's click on the manage Jenkins credentials. So same ID we need to use in the environments variable. Okay, so if you see for the GitHub credential ID, I am using the GitHub token. Then next will be the repository URL. Next is a Sonar authentication token. So here I am using credentials in which I am using the same ID that I have added in the credentials. This is the SonarQube ID. Next is a Docker credential ID. So this will be the Docker of credentials that I have added in the credentials. And last configuration is to define the image name. Okay, so that will be kodEdge -exchange rate. So let's add the multiple stages. So our first stage will be checkout stage, in which we will check out the code from the GitHub. So this is how the syntax will be. So we have to define the stage. This will be the stage name. Then it will have multiple steps. So in this step, I'm running the script. So what I'm doing checkout from git scm. This will be your branch name. So we have a branch that is main branch, and this is your remote configuration. So URL will be repository URL that we have defined here, and credential ID will be GitHub credential ID. That is this GitHub token, which will get used from the Jenkins. So this is how it will check out the code. Now next stage will be build stage, in which we will build the jar. So what I'm doing here, this will be the step. In this step, want to run the script. Script will be /Gradle w build, and here I'm skipping the test and the smoke test. Now next stage will be unit test. So here it will run the unit test. So command will be /Gradle w test. Okay, syntax will be almost same for the every stage. Now next stage I want to add smoke test to run the smoke test. So here the command will be /Gradle w run smoke test. This is how it will run the smoke test from our application. Now next stage we will add for the SonarQube analysis. So code will be like this. So stage will be code analysis. Then this is the step in which I am going to run the script. So here I am doing with SonarQube environment. That will be SonarQube. So if you see in the environment variable, if you go into the manage Jenkins, click on the system. And if you remember, we have added one environment variable. So this is the same name we will have to use there. And I'm running the command to run the sonar analysis. So that will be /Gradle w sonar, and this will be your sonar authentication token. So here what I'm doing, I'm waiting for the quality gate analysis. Okay. So I'm waiting for the response from the SonarQube server. And if the status is okay, in that case, I will send the SonarQube quality get pass. If it is not okay, so I will throw the error that is SonarQube quality get failed and our pipeline will get failed. Okay, so once the Sonar analysis is done, we will build the image and we will push that Docker image into the Docker Hub. So this will be the code for the build and push Docker image stage. So it will have step in which it will have script. So what I'm doing here, I'm taking the first commit hash. So this is how you can get the first commit hash from the head. And using this hash, I'm going to create the image tag. Okay, so I'm just defining one variable that is image tag to which I am assigning this commit hash. I'm just printing the image tag in the console. Next, I'm generating the image name with the tag. So this will be the image name. And from where this image name is coming, that we have already defined here. And to which I'm appending the image tag that we have just generated here. I'm just printing that image tag here. Then I'm just logging that push image in the Docker Hub. And this is how you can push the image into the Docker Hub. So what I'm doing here, I'm using the Docker Hub URL, Docker credential ID that I have defined here. And this is going to fetch from the Jenkins server. And here I'm building the image and I'm pushing that image into the Docker Hub repository. After this, I am adding this commit hash in the environment variable, that is commit hash, which we will use in the next stage. So once the image is pushed into the Docker Hub, our next stage will be deploying that image on the dev environment or running the container in the dev environment. So this will be the code for the deploy on dev stage. So let's understand what is happening here. So this will be the stage name, that is deploy on dev. It will have a step in which it will have script. So what I'm doing here, I'm defining the container name that will be exchange-container, and then I'm getting the image tag that is generated in the previous step. So I have assigned the commit hash to this environment variable. So I'm using the same environment variable here. Now what I'm doing here, I'm checking if the container is already running. If it is already running, then we will stop that container and we will remove that container from the Docker. So this is the command for that. I'm just checking if this particular container is running. Then I'm just stopping it using Docker stop command. After that, I am removing the container. After that, we will run the new container with the new image that we have just pushed in the previous step. So for that, what I'm doing, docker run -d, name of the container, and running that service on the 8090. So by default, it is going to run on 8080. I'm just doing the port forward on the 8090. And next, it will have the image name and the tag. So this is a generic Docker command to run any container. Okay, so once our container is ready, what we will do, we will do a health check. So let's add one more stage here. So this will be the code for the health stage. So stage name will be health check on the dev environment. So it will have a script like this. I'm just logging, performing the health check. Then I'm just adding the pause statement here. So it will just sleep for the 30 seconds just to get the container started. So this is our health URL from our application. We are using actuator, correct? Then what I'm doing, I'm just running this URL using the curl command. And I'm just getting that output into the response variable and just logging that output. After that, what I'm doing, I'm just reading that JSON, okay? And I'm assigning that to the JSON response. And from this JSON response, I'm getting the status. So let me open the URL. So I think this was the response. So when you hit this URL, that is actuator/health, you will get the response as a status :up. Okay, so we are checking the same thing here in the status. So from the response, we are getting the status, correct? And from status, we are just checking if it is up, that means our application is healthy. Else, we are going to throw the error that application is not healthy. So after this, we can add one more stage to update the image tag in the Helm chart, but that we will do when we will set up the ArgoCD and when we will deploy our application to the Kubernetes. So let's add the configuration for the post activity for your Jenkins pipeline. So what we are doing here, in case the Jenkins pipeline get failed, the control will come to this block, that is failure block. And here you can handle the failures. If the pipeline gets successful, it will go to this block. And from this block, you can handle the multiple activity. Like if you want to send the email or if you want to send some alerts, that you can do from this stage. And here what I'm doing, I'm just cleaning up the workspace. So basically it create the jar file locally, correct? Just to clean up the space, I'm using this clean ws function. So let's push this code into the GitHub repository. Okay, so if you go to the GitHub, you can see we have code for the Jenkins. Now let's go to the Jenkins. So let's click on the create job. Let's give the name and let's select the pipeline option here. Click on the OK. Now if you go to the definition, let's select the pipeline script from the SCM. So SCM will be Git. Okay. What will be the repository URL? Let's go into the GitHub and just copy this HTTPS URL. Okay. What will be the credentials that we have already added? So this will be the credential for the GitHub. Branch to build will be main. And here we need to provide the path of our Jenkins file. So if you go into the GitHub repository, Jenkins file is in the CICD CI folder. Okay. And in that CI folder, we have created the Jenkins file. So path will be like this: CICD/CI/Jenkins file. And let's click on the apply and the save. Okay, so our pipeline is ready. So let's click on the build now option here. So pipeline will get started. And let me click on this three option here. Let me click on the console output. Now here you can see the stages that is running in the background. So let me go back into the stage view. If you click on the logs, here as well you can see the logs from the Jenkins pipeline. Now if you are following this tutorial and if you are going to practice this Jenkins pipeline, there are chances that it is not going to pass in the first go. Okay, so you will have to try it out. So you will get some compilation issues and all. So you will have to find it out and you will have to work on it and you will have to run this multiple times. Now it is running the smoke test. Now it is doing the code analysis. So let me go into the console and you can see it is getting failed for the SonarQube. So if you see here, it is not able to find the task Sonar in the Gradle file. So let's go back into the project and let's open the build.gradle file that is in the parent folder. Okay, and here we will add the plugin for the SonarQube. So this will be the plugin for the SonarQube, and let's add some property for the SonarQube. So here I am going to use SonarQube function, and in which it will have properties like SonarQube project key, Sonar project name, and the Sonar host URL. That will be localhost 9001. Okay, let's refresh the dependencies. Let's push these changes into the GitHub repository. Now let's go back into the Jenkins and let's build the pipeline. Okay, so our pipeline is passed and let's go into the SonarQube server and just refresh it. Click on the projects. So here you can see our project is added here. Let's click on the exchange rates. So there is no code smell here. And also you can see the status that is passed. Okay, so let's add some code smell here. Let's open one unit test. Now, if you remember, at the time of development, I said that we are going to use this for the SonarQube purpose. Okay, so let's uncomment this and let's add the exception and let's push this code. Okay, and let's build the pipeline again. Now, if you remember, we have created one quality gate here, and if you see, we have added one condition. If the code smell is greater than 0, then quality gate will get fail. Okay, so let's build the pipeline again. Okay, now if you see, our quality gate is failed. So you can see it is showing the error signal. Let me go into the console. And here you can see quality gate is error. Let's go into the SonarQube server. Click on the projects. So you can see it is showing the failed. And here it is showing the code smell. Okay, so it is showing the remove this use of thread.slip. And it is also showing the code as well. Okay, so let me roll back this code. And let me push these changes. And let's rebuild the pipeline. Now you can see quality gate is getting passed. Okay. Okay, so our pipeline is passed. If you go back into the SonarQube server, let's click on the projects. You can see it is passed. ArgoCD setup. In this section, we will set up ArgoCD, which will automatically deploy the application. Once it detects the Docker image tag that has been updated in the values.yaml file in the GitHub repository, we will always add the image tag to the values.yaml file. So basically, values.yaml file is used by the Helm chart, which serves as a default configuration for the chart template. Basically, it defines the values that can be customized when deploying our application or service using the Helm. Don't worry, I will explain this in more detail during the demo. So once the tag is updated, ArgoCD will automatically do sync operation and it will deploy the application by creating the pods. ArgoCD will pull the Docker image from the Docker Hub using the updated image tag from the values.yaml file while launching the new pods, and the application will be ready for the use. So let's open the terminal and let's start the Minikube. So command will be Minikube start, and we will use Docker as a driver. So hyphen driver equal to Docker. So it will start the Minikube, and in which you can deploy your application in the Kubernetes. So this will be your local Kubernetes environment, and in which we are going to deploy our application. Okay, so our Minikube is started. Now next what we will do, we will install the ArgoCD. So let's open the official documentation of ArgoCD. And this is the official documentation of ArgoCD. So from here you can get the steps to install the ArgoCD. So let's run this command. So first command is to create the namespace with the ArgoCD. And let's execute this command. ArgoCD namespace is created. Now let's install this install.yaml file. So it is going to create necessary resources required for the ArgoCD. So all the resources are created. Now let's run the command kubectl get all hyphen in ArgoCD. Okay, you can see these are the resources get created. Now if you see, most of the resources are in the initialization or creation phase. So let's wait for 2-3 minutes. Now you can see all the pods are in the running state. So let's run the command kubectl get svc with namespace ArgoCD. Okay, so these are all the services required for the ArgoCD, and let's copy this service name, that is ArgoCD, and we will do port forwarding to open the UI. So command will be kubectl port hyphen forward svc slash service name hyphen n your namespace, so that will be ArgoCD, and let's use the port 8091, and currently if you see it is running on the port 443, and let's execute this command. Now let's open the UI for this. So URL will be localhost colon 8091. Okay, so this is asking for the password. So let's open the terminal again and let's run one command, kubectl get secret from this secret name, and we're just converting that into the base 64. So I got this command from the official documentation of the ArgoCD only. So let's execute this command. So this is the password for the ArgoCD. Don't include this percentage. Okay. So username will be admin and password will be this one. Let's sign in. Now next what we will do, we will create the Kubernetes manifest configuration for our application to deploy it into the Kubernetes cluster. Let me open the terminal, and I am already in the project directory. So we are going to create Kubernetes configuration using the Helm chart. So let's run the command Helm create and the directory name. So directory name I am giving as a K8 chart. Okay, so it has created the directory that is K8 chart, and in this directory it has created the default configuration. So if you want to see the configuration, what you can do, you can run the command tree and the directory name that is K8 chart. It will show you the directory structure. So these many files are getting created. Okay, so let me go into the IntelliJ, and if you see here, it has created this K8 chart, and these are the default configuration. So we can change this configuration as per our requirement. So let's open this values.yaml file, and here we will make the certain changes. So let's change the repository. So let's go into the Jenkins file, and if you see we have given the repository name here. Let's use the same name. Okay, pull policy will be always. So pull policy always means it will always pull image from the Docker hub. And let's use the tag latest, but later we are going to update it using the pipeline once we create the new image. Now next tag is image pull secret, and here we need to provide the secret for our Docker hub to pull the image from the Docker hub repository. So for that purpose we need to create the secret. So let's remove this array and let's add the name. Let's give the name as a Docker hub secret secret. Okay, so I will show you how to create this secret. For now, just give the name. We will create the secret once we complete this values.yaml file. Now let's go to the service part. So here we are defining the service type. So let's use the service type as a node port, and let's use the port as a 8080. And let's add the name for our application, and I'm adding name as a exchange rate service. So this will be useful to check the health of our application. Now one more change we need to do. Let's go into the template section. Let's go into the deployment.yaml, and here let's comment this part, that is liveness prop and the readiness prop, as we are not using in our demonstration. Now let's go back into the values.yaml file, and here I said that we are going to generate the secret for the Docker hub. So let me open the scratch file, and we are going to create one command. So using this command you can create the secret configuration for the Kubernetes. So what I'm doing here, kubectl create secret docker-registry docker-secret. So the same name we have given in the values.yaml file, correct? And here I'm providing some data like Docker username. So my username for the Docker Hub account is kodEdge. Then provide the password, then Docker email. So this is my email for the account. So namespace will be the app. So we are going to deploy our application into the app namespace. And here we are going to generate the configuration. So let me use the token for the Docker Hub. So this is our Docker Hub token. Just use it here. And let's run this command from the terminal. Okay, let's execute this command. So here you can see the configuration for the Docker Hub secret. And let's create a new file in the CD directory. So I am giving name as a Docker Hub -token dot YAML. So we are not going to add this file into the GitHub repository because we are adding the secret in the token. So we will directly apply this file in the Kubernetes cluster using the command. Okay, so our secret file for the Docker Hub is created. Now we are going to create one more file for the GitHub token. So let's create a new file. So file name I'm giving as a github-token.yaml. So this file as well we are not going to add in the GitHub repository because this file also going to contain the secrets. So this will be the configuration for the GitHub token. So what I'm doing here, API version will be the v1, kind will be of the type secret, and metadata will be, so name I'm giving as a github-token. The namespace will be the ArgoCD because we are going to deploy this secret in the ArgoCD namespace. And why this secret is required? Because ArgoCD is going to detect the changes from the GitHub repository. So it will automatically sync with the GitHub repository, and whenever it finds some changes, it will automatically deploy the new version of the application based on the changes in the GitHub repository. For that purpose, it requires the GitHub access, to which we are providing this username and password of the GitHub repository. Okay, so this will be the label. Okay, secret type will be the repository. Then this type, secret type is opaque, and this is a string data in which we are providing the our repository URL. And this is the username for the account, and password will be, so we have already created the token. So let's copy this token and let's use it into the in the password section. Okay, so our secret for the GitHub token is also created. Now next what we are going to do, we are going to create the application.yaml file to create the setup of our application into the ArgoCD. So let's create a new file in the CD folder, and name I am giving as a application.yaml file. And this file we are going to add in the GitHub. So this will be the configuration for our ArgoCD application. So what we are doing here, so this will be the API version, kind will be the application, and this will be the metadata. So what I am defining here, name of our application, so that will be the exchange-app. Namespace will be the ArgoCD, and this will be the finalizer. So what is this finalizers? This provides the mechanism to control the deletion process of resources. So here we are using the resource finalizer as this one. So what it will do, before deletion of our application, it will remove all the related resource of our application. Then it will delete the application. The next section is label. So we are giving the name as a exchange-app. The next tag is specification. So project will be the default one, and here we are defining the source. So source will be from where we want to fetch the repository or code. So first will be the repo URL. So this will be our GitHub repository URL. Target revision will be the branch name. So we are using the main branch, and path will be in which you have provided the Helm charts. So we have provided the Helm chart in the create chart directory. So I'm giving the create chart directory name here. And what will be the destination? So destination is where you want to deploy your application. So this is our server, that will be the local Kubernetes server. And namespace will be, so in which namespace you want to deploy your application. So we are going to deploy our application into the app namespace. So it will automatically create the app namespace if you have not created manually. Now last section is for the sync policy. So this options enables automated synchronization. That means ArgoCD will automatically synchronize the application when it detects the changes in the Git repository. And in the automated section, it has three options, that is prune, self-heal, and allow empty. So what is the meaning of this option? When we set this as a true, so ArgoCD will automatically delete the resources that are no longer defined in the Git repository when performing the sync operation. And what is the self-heal option? If we mark this option as a true, in that case, ArgoCD will automatically correct any changes that occurs between the actual state of the application in the cluster and the desired state defined in the Git repository. So let's say if someone manually modifies a resource like a scaling of the deployment or editing any config map, ArgoCD will automatically reverse that changes during the next sync cycle. And last option is allow empty, which we are marking as a false. So what will happen if you mark this option as a false? ArgoCD will not sync if the Git repository is empty or does not contain any valid configuration for the application. And last option is sync option. So here what we are providing, create namespace equal to true. So what I said here, that we are providing namespace name, right? So app namespace is not created. In that case, it will create the namespace automatically because of this option. And last option is run last equal to true. So what is the meaning of this? This ensures all the resources are deleted in the correct order during the cleanup activity. So let's apply this configuration. First create the namespace. kubectl create namespace app. Now let's apply our secret. So we have created two secrets. So command will be kubectl apply. Before that, let's cd into the CICD folder, and let's cd into the CD folder, and here you can find the all the files, right? Now let's run the command kubectl apply the GitHub token first. Okay, so secret is created. Let's apply the next secret. Command will be the same, kubectl apply and your secret file name, that is -f docker hub -token.yaml. Okay, so secret is created for the Docker Hub as well. And now let's apply the application.yaml file. So it will automatically deploy these configurations as well. So let's run the command kubectl apply -f application.yaml file. Okay, so application is created. So let's go into the ArgoCD UI. And you can see our application is created. Now let's go back into the IntelliJ and let's push this code into the GitHub repository. But before that, let's update our Jenkins file. And here what we will do, we will add one more stage to update the values.yaml file with the new image tag. So let's add the new stage. So this will be the stage for the update the image tag. So let's understand the code, what I am doing here. I am getting the image tag from the environment variable, that is commit hash. So this environment variable we have created in the previous stage, correct? When we deployed the Docker image in the Docker Hub, correct? So here we have created that environment variable. So we are using the same commit hash here. Okay. Then next what we are doing? We are doing the git checkout on the main branch. Then next what I am doing? I am getting the values.yaml file from the create chat folder. And in this values.yaml file, go to this image tag. If you go here in the values.yaml file, so what I'm doing here, I'm going into this image tag and finding this tag. Okay, let's go back to the Jenkins file, and I'm just updating that tag with the image tag, correct? And this image tag is coming from here. Then next what I'm doing, we need to commit these changes and push it into the GitHub repository. So for that purpose, I'm getting the Git username password from the Git credential ID. Now, if you remember this, we have added this Git credential ID here in the environment variable, and we have added this ID into the Jenkins server, okay, in the credential section. So using that, it will get the access to the GitHub repository. Now let's understand the next statement. So what I'm doing here, I'm just configuring the user email and the name. So here you can provide any email and username as per your requirement. Okay. So here I'm providing the email and here I'm providing the user name. Next, I'm adding this values.yaml file into the Git. Okay. So command will be git add and your values.yaml path. Next, I'm committing this file and last I'm just pushing these changes into the main branch. So let's commit these changes into the GitHub repository. Okay, let's go back into the Jenkins pipeline and let's build the pipeline. Okay, so our pipeline is successful and our new stage, that is update image tag, is also successful. Now let's go back into the IntelliJ and let's check the values.yaml file. So currently image tag is latest. So let me take up a new pull. Okay, you can see tag is updated. Okay, now if you go into the GitHub and let's go into the commits. So you can see update image tag to this version by this kodEdge -board CI. This is the same name we have given in the deployment configuration, or you can say Jenkins configurations. Correct? This is the name we have given for the GitHub user. Now let's go into the ArgoCD UI. So basically it will take almost 3 minutes by default to sync with the new changes. Now let's click on the application and you can see it is creating the resources and we can see there is some issue with the creation of pod. Let's go back into the IntelliJ and let's check the configuration. And what I notice is in the service.yaml file, if you check in the values.yaml file, we have added the service name in the service section. Okay, and we are not using this tag. So let's go back into the service.yaml file and let's add the tag. Okay, so tag will be values.service.name. Correct? In the values.yaml file, service.name. That will be service.name like this. Let me push these changes. And let's run the Jenkins pipeline again. Okay, so our pipeline is successful. So let's go back into the ArgoCD and let's click on the application. So in your case, if it is not sync, click on the sync app. So let's go into the application and you can see all the resources are created successfully. Let's click on the pod and let's click on the logs. So here you can see our application started successfully. Now let's go back into the terminal and let's run the command kubectl get service -n app. So this is our application service. Let's run the command kubectl port-forward, then service name, that will be extended service -n namespace name, that is app, and let's use the port 8092 colon 8080. Okay, now let's run the URL for our application. So URL will be localhost colon 8092 /latest/USD. So you can see we are getting a response from the application. Now let's do one thing. We will push some changes in the GitHub repository and let's see if it is getting automatically sync or not. So let's go back into the IntelliJ. Let's add some space here. So just I'm doing dummy commit. And let's build the pipeline. Okay, so our pipeline is successful. and it has successfully updated the image tracking to the values.yaml file. Now let's go back into the ArgoCD. Ideally, after 3 minutes, it will automatically resync with the GitHub repository, and it will automatically start the redeployment. So as you can see here, it has started the redeployment. Okay, so this is how we have successfully completed the CI/CD setup on the Kubernetes and the Docker environment. So that's it for this lecture. Thanks for watching the video.